Hey guys, we're doing on your own practice, congruent polygons and their corresponding parts, part 2. This is lesson 3.05. Alright, so which statement explains why these triangles are congruent? So what happened to these triangles? Well, they're mirror images of each other. Are they the same amount away from the line? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is a reflection across the y-axis. There we go. And that is a rigid transformation. Let's check that answer. So yes, that's right. All right, so now we have to see how these correspond. All right, so angle A corresponds with angle S. So S. Angle B corresponds with angle G, and angle C corresponds with P. So to make sure you have the right corresponding parts. All right, let's see what happened here. Now this is not a reflection because it's not a mirror image. It looks more like a rotation. And it flipped over, so it did 180 degrees. And then it would have been here. And then it went up 1, 2. Because TPC is a pre-image image. Yep. Let's check that. Yes. Alright, Cindy reflected a figure across the line y equals x and then dilated by a factor of 2. Now remember, reflections are rigid, dilations are not. You have to have a rigid transformation in order to have a congruent figure. So it has to be one of these. These are not congruent. And it is because neither of these, one of them was rigid, so one of the transformations was not rigid. There we go. All right. Which series of transformations results in an image that is congruent to the pre-image? All right. So dilation here, so it can't be this one. Translation, that is one. Rotation, translation, both rigid. Reflection, both rigid. Let's see if that's right. Alrighty. So we're starting here with this angle ABC. And it goes to this first transformation where it's not quite a rotation. Let's see what our choices are. Origin. The rotations are about the origin, and that would be here, and that's not going to work. So, but if you had a line x equals y equals x, it goes right up here diagonally. So this is a reflection over yx. And then the angle, it was dilated, so it got bigger. So we have to do image over pre-image. So our image is 1, 2, 3, 4, 5, 6. So that is 6. 6 divided by our pre-images is 1, 2, 3, 4. Just pick one of the sides and count them, and that is 1.5. Alright, and because both transformations were not rigid, we had a dilation, the pre-image and image are not congruent. Alright. So, choose the triangles can be mapped onto each other by. Alright, let's see what we have to choose first. Definitely not a reflection. 180-degree rotation, possibly. Across the x-axis, no. We reflect it across the x-axis. Flip it would face this one, so no, that wouldn't work. A 90-degree rotation followed by a reflection over the x-axis. 90 degrees take us here into this quadrant. I think this one's 180 degrees about the origin, and that is a rigid transformation. They are congruent. Let's see, because yeah, that straight line of rotation, yeah, there we go. All right, ABC to become this first image here, that looks like a reflection over the x-axis. They're reflected, same distance away. And then it was translated, it looks like 1, 2, 3, 4, 5 to the right. And those are both rigid, so they are congruent. Alright, so this is the pre-image, and then it becomes this. Let's see what our choices are. Translating 5 down. So if we took C, 1, 2, 3, 4, 5, that could work. What's the next one? 9 to the right. So if we're here, 5 down, and then go 9 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are both rigid, so they are congruent.